So, hello everyone, and welcome to the talk Full Stack Observability: One Tool to Rule Them All. So, my name is Serhiy Boychenko. I am software engineer at Thousand Eyes. I have had an opportunity to work on an integration with an observability tools, and that's the experience I will be sharing today with you, and something more, of course. So, I studied here at Coimbra, and I really like coming here at every opportunity I have. So my interests in the domain of software engineering are distributed systems and game programming of a nighttime hobby. Yeah, so I would like to start the talk with a bit unrelated topic. Probably we have some Formula One fans here. Definitely some of you have watched some races. Most of you probably know the concept, right? Some time ago, I did research on the sensorial data which is being collected on the Formula One cars. And I was actually quite surprised by how many sensors are currently installed on those Formula One cars. It's around 6 sensors. Oops. Okay. It's around 600 sensors which are constantly sending the data to the crews in the pit, and they are kind of observing what's going on the track. They are looking on how the car is performing on the track. But if you think about modern web applications, basically you can quickly understand that while Formula One is still a complex apparatus, modern web applications can quickly surpass in complexity the whole peloton of cars racing on the track. And it's up to us, to software folks, to actually, take advantage of those signals and to make sure that our applications are kind of running properly, running according to the specifications. What I want you to take from this introductory slide is that, okay, probably telemetry itself doesn't win the races, but it definitely plays a role in winning the race. Now, back to work, back to the software world. So whenever we are developing a product, we usually are thinking about the customers, right? We are building new features, we make sure the customer can use those features, but we also should be thinking about ourselves, about our developers, right? Because in the whole product development life cycle, of course, we develop new features, but we also have to maintain those systems. We have to keep them running 24/7. And it's important to have good tools for the job, especially when the problems are hitting. And problems will hit. As humans, we have been kind of always trying to find the best tools for the job, and it was a matter of survival at some point back in time. But guess what? Today, it is still a matter of survival. It is a matter of survival of our products, of businesses, of companies. Okay, enough of motivational speeches. Let's get into business. So, when I told you about the troubles, probably something clicked in your head and you thought about like, okay, probably monitoring and logging is something I know about. And whenever someone is telling you, okay, the service is running slow, so probably you will go to your monitoring dashboard, you check the metrics, you see that CPU is being throttled, you increase the CPU, restart, and then you fix the problem, right? You will be looking for the problem afterward. But you solved it. But what if someone is coming and saying to you something like, hey, we have a customer which actually complains about having slow requests. I mean, monitoring might not be helpful there. Because of the aggregations, you might not even see like any latency changes, any significant latency changes in your monitoring graphs. So at this point, you think about other tools which we have at hand, right? Logging. So you grab a coffee, in this case, or the drink of a choice. You check the monitoring dashboards again, just to make sure that you didn't miss anything important, like no detail has skipped when you first checked it. And then start examining the logs. And if you have a centralized solution, nice. You can go and query. If you don't, well, I feel for you. You will have to SSH into the pods and, try to find out what's going on. But logs can help you. Sometimes there aren't enough logs, right? And then you will have to analyze and debug the code using your IDE. You will have to reproduce the issue, and finally, once it's reproducible, you will fix the issue. And during all this time, during all these operations, you were using multiple tools, like Grafana and Prometheus for metrics, Kibana and Elasticsearch for logs, Sentry for exception alerting, Alert Manager for metrics alerting, and then maybe Looker for analyzing if there were other customers which might have been affected by the same problem. And don't get me wrong, this works, but it has some problems, right? So you have the data, which is located on like different systems. And if you need to correlate this data, either you have a good aggregation tool, or you are an API guru and you will be coding like mad to get things together. Then there is a problem of the tool sprawl, right? So in that case, we are using 5 tools, but for some legacy system, you might be having another tool. For Amazon, you started migrating to Amazon, you would be using CloudWatch because you still don't get metrics in your Prometheus. So it's definitely a lot of tools to look into, a lot of tools to maintain. And finally, you are vendor locked. Even for simple things like, okay, I will switch Sentry for something else, you will probably have to import new dependencies, recompile all your code, change configurations, and maybe then it will work, right? What if I told you that we can do better than that? What if I told you that we have one solution which would be the single source of truth? It will kind of get all the data in the same place and allow you to play with the data, to analyze this data. Of course, there are some commercial tools which allow this, but I mean, in this presentation, I would like to present you some open source alternatives which you can use to build the full stack observability solution. So before actually going and building the full stack observability solutions, for some of you, some of these concepts might be quite new. So let's define the observability first. So as per definition, observability is basically an ability of understanding the system based on based on the signal it is emitting. And you will stop me here and say, hey, isn't monitoring is already doing that? Well, kind of. Monitoring is actually more of a high-level view of the system. But observability is like a magnifying glass, and it allows you to focus on a much lower level on the data you're working with. Like, you can literally see what is happening with a determined request. The observability is built using the observability solutions is built using 3 different signals, metrics, logs, and traces. So for the metrics and logs, you probably know more or less what it is. Traces, probably some of you heard this for the first time. So let's try to see what traces are. So when we are talking about tracing, we are mostly interested in the distributed tracing. So distributed tracing, in a nutshell, is a technique which basically allows you to kind of correlate the requests which are going through your whole infrastructure and which belong to the same transaction. So for example, if somebody is making a request to a microservice and that microservice is calling as part of the scope of the same request is calling other microservices, Tracing basically allows you to aggregate all the data together and show you as a single object of the timestamp events called traces. Now, the trace is the object, which is a collection of the timestamp events. But what actually those events are the spans. And this is important to get those two terms understood well before you are going into the development of the full stack observability solution. And it's actually spans which include the useful data. The application which emitted the span, basically all the data reside in the spans. Now, how does this exactly work? So the trace context, this single transaction which we would like to look into, the trace context is propagated through the HTTP headers in the modern instrumentation libraries. And then, of course, you need an instrumentation library attached to your application, which will know what to do with this tracing context. In this case, for example, we have an HTTP request which is hitting the application A. Application A is instrumented, so it will inspect the headers. It will see that there is no tracing context there, so it will create a tracing context and further propagate it to the other calls which it is making. So in case of the call to the application B is not instrumented. Therefore, we will not be getting like any interactions which application B did with other system, but still we will see that we call the application B in the traces. And that's why it's important when you are thinking about implementing the full stack observability solution to instrument as much as you can, as much as possible. In case of the application C request, it is an instrumented application, so it will detect the tracing context, and then it will kind of attach the new data, the new span data to the context and propagate it further to other calls. So as you can see, my SQL request is not really that doesn't have any tracing context, because some tools, like you are not sending an HTTP request to MySQL database. Okay, so now that we have a bit of a basic understanding of what are the key concepts are in the full stack observability solution, let's actually start defining the full observability solution itself. As the name suggests, full stack observability solution is about gathering data around the whole stack, right? It's not only about the front end and the back end. It's about all the data you can get. And this includes network data, this includes external cloud providers data, data storages, so basically everything you can get, all right? One of the main components in the full stack observability system which we will be building is OpenTelemetry. OpenTelemetry is an open source project which provides a large collection of tools for instrumenting different applications in different technologies. It also provides tools for extracting the data from the instrumented applications and the tools to export this data further to the storage or some other backend or even other collector for further processing. The nice thing about OpenTelemetry is that it provides the vendor-neutral data format. So the vendors which are interested in integrating this OpenTelemetry can develop their own tools, and then you can seamlessly integrate them into your infrastructure. And this is actually what brought a lot of attention to this project, and this is what actually brought a lot of traction in the industry to this project. A lot of major software vendors created their own tools, and now you don't need much, but just including a couple of components and kind of configuring them, and that's it. You have your data from AWS or Google Cloud or Azure. Okay. So, OpenTelemetry instrumentation. How does it work? Of course, it works differently for different languages which we are available, but I will probably propose to look into the Java one, the Java instrumentation. So Java instrumentation injects the byte code into the application code which is running, and basically it creates spans around the points where your application is communicating with different system components or the libraries which are supported. This can be a database call, this can be an HTTP call, like a Kafka message being published. So it really has a lot of frameworks which are supported by the OpenTelemetry Java instrumentation library. Basically, and what you will need to do for integrating the Java instrumentation into your Spring application, for example, Spring Boot application, is simply providing a JVM parameter which will basically allow to attach the OpenTelemetry agent to the code you are running. Okay, so let's quickly take a look at this code. So we have a method which allows to place the orders. So we get the prices for the products which we passed through the products parameter, and the products client can be, for example, a fan client which you are using to fetch the data from another microservice. Then we do a total price calculation. It's done inside the same application. Then we have the user's client, which gets the user's address, for example, from the user service. Finally, we create new order and we save the order in the database. So what the instrumentation library will do, it will detect that the product's client is an external call. The user's client is an external call as well, and the repository call, once again, it's a way of saving the data into a database, an external call. So it will create spans around all of those calls, and you will kind of get in your trace the waterfall view of the calls. We will see it in the demo a bit later, but that's how the instrumentation works. Automatic instrumentation works. Manual instrumentation, you basically can import the OpenTelemetry dependencies into your project, and for example, you can put a span around the total price calculation. You say start span, end span, done. And yeah, the good thing is that you can combine both of the techniques when you need to get some more data from some specific application execution methods. Okay, so first we talked about how we are generating the data. Now we need to talk about how we are collecting the data. And here, one important note. So this is the term which is used in OpenTelemetry, but collection here is really about getting the information from the instrumented applications and exporting it somewhere else. It's not about storing it, okay? Just keep this in mind. For the purpose of data collection, so we have the OpenTelemetry collector. OpenTelemetry collector is a stateless application, more or less stateless. We will not go too much into detail, but it's mostly stateless. Where you have to configure the receivers. So receivers basically allow you to connect any external data source to get the telemetry data, so traces, metrics, and logs. Yeah, it supports different formats. different technologies, but what it does, it translates the data from different formats into OpenTelemetry format, this vendor-neutral format of OpenTelemetry. Then the data is processed. Some simple processing can be done, like filtering. Imagine you don't want outdated data, or you want to enrich the data with some attributes, you want to batch your data. So processors allow to do this kind of operations with the data points. And finally, you have the exporter, which we also must configure. So processors are optional, but receiver and exporters are the must have in an OpenTelemetry pipeline configuration. So the exporters allow you to export data to different technology which support, which are kind of integrated with OpenTelemetry. It can export data in OpenTelemetry format, but it also can export data in any other formats, depending on the tool you're integrating with. So for example, in this collector, we have configured two pipelines. The metrics pipeline, which receives the data from internal infrastructures through the HTTP receiver, and the data from Amazon using the CloudWatch receiver. We do some time filtering because we don't want the outdated logs, for example. We append some attributes, we batch it, and export it to Prometheus. And there is also the traces pipeline, which receives the data through the gRPC receiver. So here, HTTP and gRPC receiver, they basically expect already OpenTelemetry data format. So just for small detail. And then we transform the data a bit, we batch it, and export to two different exporters at the same time. So it's possible to configure multiple exporters. You can export the data to multiple endpoints. The data storage. That's where the things actually start getting interesting. That's where the mandate of OpenTelemetry is ending. And it becomes up to you to choose the data storage. But I wouldn't be worried at this point about data storage too much, mostly because data storage is kind of dependent on the rest of the solution, the rest of the full stack observability solution, backend and frontend, which will be working with the data. Sometimes different full stack observability solutions, they allow like for same data storage to be reused, like they integrate with same technology, but it couldn't be the case. So be careful and like don't be worried about data storage now. So in very simple terms, in a very basic setup, we will have something like this. So we have a front end, which has OpenTelemetry JavaScript instrumentation library, and it is exporting traces, metrics, and logs to an OpenTelemetry collector. We have a backend, which also is instrumented and exports traces, metrics, and logs into the same OpenTelemetry collector. What I would recommend is to probably always have the OpenTelemetry collector in the middle. It's quite an easy service to maintain because it's stateless. But in case, for example, you would be configuring your front-end and back-end writing directly to observability solution endpoint, in case you, for example, decide to switch to another observability solution, you basically will need to reconfigure all your applications. While if you have an OpenTelemetry collector in the middle, you just reconfigure it once. One important note here, so I didn't put the storage there. Normally, the observability solutions, they already provide a collector of their own, so you can chain multiple collectors, as I mentioned before. And then inside, it will be kind of routing the data whenever it's in the database where it will be stored. So that's why there is this observability solution endpoint there. Now, yeah, we have checked the actually very simple use case, and maybe many of you have already tried this at home. Now let's explore a bit more what full stack observability solutions have to offer. And there are some very interesting features. Don't ask me why, how they don't ask me how they implemented it, but especially in the commercial tool walls, there are like very interesting features. The one which I like a lot is the service dependency graph. So this is basically a single view where you can see all your services with some basic information like latency, errors, like error percentage, throughput, and it's a graph. It's a graph where the nodes are connected. The edges represent the communication between the services. Sometimes there are color codes which help you to understand whether the application is having some troubles. It's like you can configure thresholds, and then the node will be turning green or red depending on how it's doing. Service dependency graphs are actually quite common in full-stack observability solutions, the open source ones, and it could be very useful if you need to quickly check, like, hey, what's happening with my application? You don't need to go through end dashboards to see what's happening. The real-time user monitoring, this one is more front-end oriented and is mostly used for kind of trying to understand what customers are doing with your application, trying to study the customer experience. From my experience and the tools I have been using, basically most of the full-stack observability solutions will already provide you a set of predefined dashboards. So you just need to plug it, and you need to plug the data source, the instrumentation library, and you will start seeing data in those predefined charts straight away. And those could be like performance-based charts where you can see like, okay, how much time did it took for the first byte to arrive? How much time did it took for DOM to load? But it also includes like analytics graphs where you can see user demographics, where the users are making requests from, what browser the users are using. So it's not only useful for developers, it could be also useful for other departments in the company. One interesting thing is session replay. It is still part of the real-time user monitoring. But unfortunately, it's not an open telemetry standard. Nevertheless, it's quite easy to configure, at least for some of the tools. And basically, what you will have is a YouTube video-like thing, a frame where you can literally see what the user is doing on your page. So, session replay allows to collect the clicks, the keyboard inputs, the scrolls, like all the interactions the user is doing with the page, and you can watch it in like a YouTube-like video. Yeah, just be careful about this one because of the sensitive data, right? I mean, the page, you will see it in the demo. So the page could contain some sensitive data, and you probably don't want to store it in you know, unprotected or not very well protected environment. Synthetic testing. So synthetic testing is a technique which allows you to periodically inject traffic into your web applications. This could be useful, for example, if you have a page which has low traffic and you want to make sure that the application is working, that page is working correctly, that page is accessible. You also might want to configure synthetics to check if the external service providers are up and running. And synthetic testing allows you to basically configure the probes to do low-level network stuff, but also quite complex operations with your application. Like it could do login and check some page and do this and that. Actually quite powerful stuff. Unfortunately, it is not supported out of the box by many of the full stack observability solutions, but there are tools which kind of easily integrate with OpenTelemetry, and you kind of can just plug it into your collector and get this data straight away. So this is a bit more complex, as you can see. So this is what we're gonna see in the demo, very briefly. I'm not going to go into much details, but at the end I have my my GitHub linked, so you can get all the instructions on how to run similar setup to this. So all of our services, front-end, product service, order service, user service, are instrumented and sending traces, metrics, logs to the OpenTelemetry collector. The front-end is also sending the session data, so this is the session replay feature to the OpenObserve tool. So OpenObserve, Cygnus, and Jagger are the three full-stack observability front-ends which we will be looking into the demo. All this data goes, of course, not the session data, but the traces, metrics, and logs are going through the OpenTelemetry collector. We also have the cloud prober, which is injecting metrics into OpenTelemetry collector. And at the same time, we are publishing to the three different full-stack observability front-ends. Okay, time to pray for the demo gods. So I have everything up and running already. So this has a lot of Docker containers here. Basically, let's quickly look on what's needed to whoa. Okay, sorry. You can see it well, more or less well. Okay, so that's basically what you need to do to instrument your Java application. So you have a couple of environment variables which we need to define, like to say where we should be exporting the data to and what is the method to export the data to. And then we need to attach the Java agent to the application using this JVM parameter. So that's basically it. You have your automatic instrumentation. For a Java application in place. Now, for the front end, it is a bit trickier, but nothing to worry about. So here we have the tracing.js. So I created a very simple view front-end, view application front-end. Basically, yeah, this is the configuration. So we import a couple of things from the OpenTelemetry framework, and then we do a configuration similar to Java. Right? We are saying where we export the data to, like what's the name of the service, some properties. Yeah, and that's basically it. Then for the session replay, we do the similar thing. Yeah, so we define this OpenObserve thing. So all these properties are actually provided by the tool. I just copy-pasted them and it works. What you will need to do, however, is to import both of those files in the main JavaScript file. And for example, as you can see, in the products view, we don't have like anything but simple script and HTML code. For the cloud prober, so we define two probes. One of the probes is for periodically send some HTTP traffic to Google because, for example, we are integrating with Google or something like that. And then we have our product service probe, which is also pinging the product service from time to time. Finally, you set this configuration to say where to export and how to export this the metrics data. So this is on the part of the data generation. Now for the collector, it's really simple as well. So we have here the receiver, which has which receives data through gRPC and HTTP protocol, and then the exporters. So we export to different full-stack observability frontends. Yeah, and basically then there are your pipelines, the metrics pipeline, the traces pipelines, if I'm seeing it correctly, and the logs pipeline. Yes, the logs pipeline. So as you can see, we receive on the OTLP receiver, and then we export to multiple endpoints. Now, let's actually see this in action. Okay, so this is a very simple view applications. I'm not a front-end developer, so I did my best. So we can do a couple of clicks here and there. Okay, orders failed. Nice. It's still failing. Okay, that's what we want to see. Okay, never mind. So, after a couple of seconds, basically after you are sending the traces, your collector will pick them up, and observability solutions will start displaying them. So first of all, let's take a look in Jagger. I believe we need to refresh. Okay, so if we look into our, is that front end which is selected? Okay, great. So you can see that we did a couple of requests, and you can see that, okay, we had a failure there. The nice thing is that all of the services are instrumented, and we can see this very nice waterfall chart, which shows you exactly what application is doing. So here is MySQL integration. Like you can see how the spans were generated through the whole tool. And then at the end, you see that there is something wrong with the order service, right? We can see that this exclamation mark here. So we can click there and like to check for more details. And yeah, you even have the logs. And it will show you the exception. I mean, would be helpful, right? Then Jagger also show you the service dependency graph. Yeah, not this one, I don't like this one. But this one I think is a bit better. So you have your front end. It shows the number of requests we have sent from front end to different services, like the order service, the product service, what order service was doing as well. So you can see that the order service sent 81 requests to product service. It's pretty basic, but can help. And then we have also some monitoring dashboards, and those are coming kind of out of the box. You don't need to configure much to get those up and ready. Now we have another tool, the signals. Let me refresh. Okay, so we have all of our instrumented applications here. So once again, we can go to the front end. Yeah, you also get like some dashboards out of the box. So that's the logs, I believe. You can see, no, those are the traces. So yeah, you can see some traces from the cloud prober. So it's trying to access the page which is not really accessible. But if we filter a bit, we will find our front end. And here you can see exactly the same request which we did, the 501. And it basically provides you a very similar view. Now, the signals, it also has Kibana-like style logs where you can go and check what was going on, right? So yeah, you have a browser to see. Then dashboards, I don't have any configured, so I believe you also have alerts. Yeah, basically, this tool is already more complex than Jagger and provides you more integrated tools in, right? It looks a bit more like an enterprise tool. Then finally, we have OpenObserve. So OpenObserve, once again, it has metrics, logs, traces. So traces, once again, you can find the trace which was problematic somewhere. Yeah, we can filter, but I just cannot see very well from here how I should be filtering. Anyways, then we have sessions, I believe. No, streams. There is somewhere the replay part. No. Real-time user monitoring. Exactly. So those dashboards are already coming for free. You kind of plug the data source and it already starts showing you different types of data. But then there is also this session replay thing, and you can basically click play, and you can see what I was doing there, right? Could be useful. It's like standing next to the shoulder of the customers and watching what the customer is doing. Okay, so let me switch back to the presentation. Okay, so by now the story is nice and easy, but I mean, don't be eluded. It's not that nice and easy. Of course, everything comes at a price. So probably the first challenge you will be facing is actually getting all of your services instrumented, especially if you work in the multi-team environment. Basically, yeah, different priorities, different products, different whatever. People will find any excuse to not do any extra work, unless they are super motivated and convinced that this is useful. Then there is the cost of storing the traces. Probably you already store your metrics and logs, so this is this cost can be neglected. We'll need to store also the traces, right? And this is additional cost, and those can skyrocket. You have the tools like probabilistic sampling and scenario-based sampling to reduce the amount of traces you want to collect, because most of the traces won't be useful, right? You just want maybe the problematic ones, or I don't know. And of course, if you are going with the open source solution, you will have to maintain it, right? And I believe this is the hardest part. But on the other hand, you will need to maintain one solution and not 5, not 6, which we have checked before, right? So if you think carefully, it could be an advantage. And yeah, finally, when you have the real full stack observability solution, it can actually help you in a lot of cases, because like when we are troubleshooting those really tricky problems to solve, basically every bit helps. And like you might be looking into exceptions and it won't be making any sense. But if you have network data to show you that something was happening on the TCP layer or whatever, yeah, it will definitely help to solve the problem faster and more efficiently. Finally, before we wrap up, a couple of recommendations. Yeah, so if you plan to go ahead with full stack observability solution, start simple. Start very simple. Like you need to understand very well what's going on. Things like there will be a huge amount of data if you try to instrument all of the services at once, but you probably try to narrow down the scope and play a bit with the tooling which you plan to integrate into your full stack observability solution. And I think the second tip or recommendation is that most of the services I have shown you, they are open source, right? Most of the tools are open source. But they also provide a cloud hosted version, which actually comes with a free tier. which sometimes is actually quite generous. You can get quite a lot of traces in. So maybe before, like trying to rush and self-host some of this open source solutions, maybe try to play with the cloud version first to see if it's useful for you, if it's useful for the company, show it to your colleagues. So yeah, this way you can make smaller steps, but the steps will be definitely stronger, let's say. And yeah, this is it. Thank you, and any questions are welcome. Yes?
First of all, thank you for the presentation. And I would like to understand more detail regarding the sampling and how, based on your current experience, like based on the based on your current experience, what are you doing to handle the costs on the production environment? Is just the sampling or something else to handle that?
Yeah, in case of Thousand Eyes, basically we so far are employing the probabilistic sampling. So it's kind of the easiest one, and once we gain a bit more experience, we can maybe try like scenario-based sampling or, but yeah, we also do not retain the data for a long time. We clean it very often, like it's being auto-cleaned very often. I mean, do you care about the trace which happened a year ago? Probably not, right? So, thank you for the question. Yes?
Is there such problem then, for example, when application dies so as I understand, this receiver is stateless and it sends events in batches or traces or logs, and they getting lost, and the latest one are usually the most relevant for troubleshooting. Or
so maybe I didn't understand you right. So what you mean is that you are getting some delay in the data which is coming to you.
Before the events are sent to the collector, and if something happens, like, I don't know, out of memory or something like this,
so
they are not getting sent, and if they are in memory, they just getting lost.
Exactly. So first of all, collector, it has a queue. That's why I was telling it's kind of semi-stateless. It has a queue. I believe by default it supports up to 1,000 of batches. Batches, you can configure the size of the batch, and it will probably depend on your setup. So you can say, okay, the batch is 100 messages, for example. And in case you're not able to send it to the front end, for full stack observability front end, it will keep it in the queue. And it will keep it in the queue as long as the queue is not full, because once the queue is full, it will start discarding the batches and will be storing the most recent ones. Yeah. Thanks.
Okay, thank you.
Hello.
Hey.
Did you notice some overload issues with using OpenTelemetry for Java or for the front end, like some application degradation, service degradation, by using this?
What they're claiming on their web page, I didn't measure it myself, but what they're claiming on the project web page is that it shouldn't be more than 1 or 2% of performance degradation, at least for Java. I'm not sure how it is for other languages. I'm not sure how it is for JavaScript, but that's basically what they're claiming.
Okay, thank you.
Yes?
You mentioned that there are sometimes teams that don't implement OpenTelemetry or they don't implement out instrumentation. Do you have any recommendation how you can solve that problem? I know technology like service mesh, but could that solve the problem like one team is not implementing OpenTelemetry, so you are blind starting on that point? Or do you have any suggestion for that?
At Thousand Eyes, we are using Istio service mesh, and actually service mesh can be helpful with that if the Istio service mesh is instrumented. So you probably cannot see as detailed traces as you would be seeing with the instrumented applications, but still you will be getting some data.